In math, there are several different ways to prove something. One of those ways is proof by induction. This involves proving that whatever statement is true for the first case, so when n is equal to 1. But then you assume that it is also true when n is equal to any random number. Let's call that random number k. If this statement is really true, then it would be true when n is equal to k plus 1 as well. So if these three parts are true, then the statement must be true for all values. But keep in mind that proof by induction is only for positive whole numbers. Proof by induction has several applications in different areas of math, such as sequences and series, divisibility, functions, and differentiation within calculus. I'm going to make a separate video for each of those, so keep an eye out. But in this video, I just want to go over the general structure of how you would approach a proof by induction question. The first step is called the basic step, and this is because you do it for whatever value is first within your proof. So usually it will tell you prove that this is true for all positive whole numbers. So that means it starts from 1 and goes up 2, 3, 4, 5, 6 to infinity. So you would start by 1, but sometimes it tells you that the first number is 2 or 3 or 4, and then you would start from that number instead. And all you do is prove that the left-hand side of your argument equals to the right-hand side of your argument. This is a simple direct proof. If you want more information on direct proofs, watch the video in the card above. Now, the second step is the assumption, where you assume that your argument is true for when n equals a random whole number, which we'll call k. And you have to say that you assume this is true, and then you have to write out the statement with k in it to show that this is how the statement would look. And this is a very important step. If you leave this out, then the rest of your answer falls apart. The third step is called the inductive step. This is where you show that whatever value you chose, k plus 1, is also true. And you can only use the left-hand side. Unlike with a direct proof, you can't show both the left-hand side and the right-hand side. You have to use only the left-hand side and show that it would equal when k plus 1 is put into the n value. And this is the step I would say that people struggle the most with, because you have to factorize and you have to know your math well in order to be able to show that this is true. Then the last step is the conclusion, and you have to actually write a conclusion in a very specific way. You could format it in any way, but there are a few important keywords you need to include. So the specific way that I format mine that I've memorized is, since P1 is true and Pk plus 1 is true whenever Pk is true, Pn is true for all values of n belongs to z plus. Now, these are quite mathematical terms, but I write it like that because I shortened it kind of. So P1 is your basic step. P is basically the proposition or argument that you're giving. Pk is when n equals k. The number under P is basically when n equals to whatever number. So Pk plus 1 is when n equals k plus 1, and Pn is just the argument in general, the entire thing you're trying to prove. N belongs to z plus is like the mathematical way of saying when n, the number you're trying to substitute, is any positive whole number. So z means whole number, and then plus just means positive whole numbers. And this weird sign in between that looks kind of like an E, that's kind of to say like n belongs to, or n is part of like this set of numbers that you're defining as positive whole numbers. That is kind of the basics of it, how you would go about structuring the question. And if I were you, I would just memorize this last conclusion. Each of these steps are very important and you need to include all of them, otherwise you won't get all your marks. You can formatted a bit differently using like pk, n equals to k, whatever you think would be easiest for you to remember, but it's important that you include all of these steps. And remember to watch out for each video of the applications I gave, like sequences and series, divisibility, all of those. I will go in detail with an example so you can see how this would look.